All right, so when I was in high school, we took physics as juniors, and my physics teacher said, okay, guys, you haven't had trig functions, so I'm going to teach it to you. Just memorize it. I was never one to use, like, anagrams or something, whatever they're called. I don't know what they're called. But these memory kind of things. But other people do. So Sohcahtoa is used for trig functions to help students remember how to solve angles and sides and all of that stuff. So let's say we have a triangle, okay? And this works with right triangles. Theta is our angle, okay? Theta is our angle. Our largest side is called the hypotenuse, okay? The one closest to us, not farthest away, is called the adjacent. Hey, this person is adjacent to me. They're right next to me. And then the other side would be called the opposite. Right on the edge, okay? Now, if we were to look at this, this angle up here, let's say it's top angle, well, then things just flip around. Our hypotenuse is still the longest side. Our opposite would be down here, and then our adjacent would be the one closest to the angle, okay? So those are the four things that we're dealing with. An angle, if you didn't know, maybe I should say this, this is the Greek letter theta, all right? It's small. Is that small? It's uppercase? Uppercase. Small. Lowercase theta. What would be the big one? T? You should know. Okay, so anyway, yeah. So we always need a right angle, okay? Or if we don't have a right angle, we can't use trig functions, okay? So we're either solving for one of these four things. So hopefully by now you've realized that S stands for something. It stands for sine. O, though, would be opposite. H is hypotenuse. A is adjacent. H hypotenuse. O opposite. A adjacent, okay? So we have these things called calculators. When I was in high school, we first started doing trig functions. I think we did them longhand way. Now, if you were to ask me now how to do that, I have no idea, nor do I care, because we have the calculator. All right? So S stands for sine. It's actually S-I-N-E, but we shorten it by a whole one letter. Amazing. And that would be opposite over hypotenuse. Next would be cosine. It'd be C-O-S-I-N-E. Okay, of theta, our angle, and that is adjacent over hypotenuse. And then we have tangent, which we shorten to tan, and that would be opposite over adjacent. Now, if I look at my calculator, I have sine, cosine, and tangent. All right. Now, a lot of you have graphing calculators, okay? And if you have a graphing calculator, most likely you have a TI, all right? TI 8 million. I don't know what they are these days, okay? Doesn't matter. Now, your math class, you are going to use, help me out, radians. You're going to use radians. But in physics, we have to use degrees because we're talking about angles in degrees, not radians. So if you have a regular calculator like this, no big deal. You'll see when you turn it on, well, mine says syntax error. But anyway, we turn it on, you'll see the little DEG somewhere in the bottom. Perfect. If you have a graphing calculator, make sure it's in degrees. Obviously, when you go back to math, make sure it's in radians or ask your teacher. All right? And the way to do that, I don't have one on me, but you'll find a mode button. I think for the most part, they're up here. Okay? You're going to find your mode, M-O-D-E, hit it, and then you're going to go from radians to degrees. Okay? So one of the things that happens, and students will make mistakes in class, and I'll be like, how did they get this number? Because all their work looks right. It's because they have it in radians and they didn't put it in degrees for our class. Okay? So here's the three big equations, if you want to call them that. Do you have to memorize them? Absolutely. Or remember the Sohcahtoa, and you could use that. All right? So let's just go through. Now, there's an example problem sheet that you're going to go over. But let's just do one here, just so we could kind of see what to do. Actually, we're going to do two. We'll do one just solving for a side, and then we'll do one solving for an angle. Because that solving for an angle stuff, students seem to butcher quite a bit. All right? Some don't. All right? So let's say we have our angle here, right angle, here. We have our angle theta here. Let's say it is 30 degrees. I'm going to put 30.0, even though I don't really care about that. Okay? And let's say the hypotenuse is, I gotta quit using so many threes, right? I'm using threes for everything. Let's say it's 5 meters long. And let's say I want to find this side. I call it y because it's the y direction. I call this down here because it's the x direction. Let's say I want to find y. All right, so we have our angle. That's theta. Fantastic. We have our hypotenuse. That's great. You know what that means? Can't be tangent. Has to be one of these two. If we're solving for y, then that's the opposite. It's opposite of y. So we have sine of our angle. If I was by myself in a room, I would stop it. I would like start all over again. All right. Sine of 30 degrees is equal to opposite, which is y over 5.0 meters. And then we do the multiplication, crisscrossing, and all that good stuff, and we get y equals 5.0 meters sine of 30 degrees. Okay, and we get a number. Now, let's talk a little bit about significant figures when it comes to trig functions. We have this amazing thing in my room called the Mad Esmen Rule, or the Esmen Rule, or whatever. So, if you don't know who that is, that's me. Me. So, I don't know why, I look over here like this is the camera. I keep doing it. Or maybe that's the student I always look at in class all the time. So, this is 2.5. The Mad Esmen Rule is this idea that no matter what the angle is, it could be 3. And when you take sine of 3, I always use 3 significant figures. Always. Okay? It's just what I do. Because sometimes we'll measure angles or whatever. You get, oh, it's 5. Oh, okay, I'm going to take sine of that. I hate to always have one significant figure. Okay? So we're going to say, whenever we use a trig function, that for that trig function, it's always going to be 3. So 5.0 would be 2. Sine of 30 would be 3. We're multiplying 2 and 3. It's going to be the least amount. That's 2. All right? Oh, and I did put a vector sign over it. That vector sign's not necessary right now. That's my mistake. It could just be y. All right? Now, let's say we do this again. We do a different one. We don't need to make them crazy hard, but let's say we're looking for the angle. All right. So, same sort of setup. I always like my angle to be down here because maybe it's like flying a kite and you got the kite string, or you're looking up at a building or something like that. I always think that's the most reasonable angle. And we don't know it. And we're going to say this is 10 meters, and we have this being 6 meters. It's kind of goofy to have it 6.0, but we'll have it be 6. You know why I say it's goofy? It's because this kind of means if you're measuring something, use the one device to measure this, because you can only measure to the ones. And down here, it's like, oh, I must have had a better device that I measured with. That's kind of goofy, but so be it. So we're trying to figure out what theta is. So we have the hypotenuse, and then 6 meters would be actually the adjacent. So we're looking at cosine. So cosine of theta is the adjacent over the hypotenuse. Now this is called what? Inverse cosine? Inverse cosine? Yeah. Sometimes with math terms, it doesn't matter. I know how to do it, okay? I mean, you can name things all you want. You can name things about force, but do you really need to know it's force? No, you need to know how to use it. I'll tell you a good story about that later with Richard Feynman. Great story about his father and him. Richard Feynman is one of the best physicists since Einstein. Okay, and I'm not a big fan of Einstein. But his dad would say basically he would explain how things worked. So, but he never really called him by name. So Feynman's older, and he's somewhere, and somebody comes up to him, a physics student or somebody doing research, and said, "Hey, Mr. Feynman, I want to tell you about this whatever," and he named it. And he's like, "I don't know what that is." And then the guy explained it, and then Richard Feynman knew what it was. It was actually something he had already done, or he did himself. So it was kind of funny. All right, how do we do this? Well, if we look at our calculator, you could make that 0.6, but I don't do that. I just put it on the calculator once. We go find cosine, and above it you're going to see cosine to the -1. That's what we have right here. So to get rid of this cosine, to take it, let's say, to the other side, it's cosine to the -1. So we have inverse cosine. You hit the second button, then you hit cosine. It'll give you cosine to the -1. 6. And we get 53. Okay. Now, if we go by my rule, see, we did a trig function on these numbers. I should actually have 3, so it'd be 53.1. If you just go with the least amount in the numbers when you did this, I wouldn't mark it wrong. Right? So there's the simple trig function. Some people aren't going to like it. Some people will like it or don't really care. Basically, what we're going to use for most of the year, we'll just use mostly sine and cosine. We don't mess with tangent too much. Once in a while, but not too much.